Picking up where we left off last time, let's talk about writing the formula for an ionic compound. So oftentimes, when we are discussing ionic compounds, we won't actually know what the formula is right off the bat. Instead, what we might know is maybe that we have a compound that is made of this metal and this non-metal. And so at that point, it's up to us to figure out, okay, if I have these two things coming together to form a molecule, what would be the formula for that molecule? And it's actually not too bad. It's not very difficult to figure this out because there is only one way for most of these molecules to come together. As with all things in science, there are exceptions to the rules. But we're going to be focusing on the ones here where there is only one way, for example, for magnesium and chlorine to come together. If you have an ionic compound that is made of magnesium and chlorine, the only structure, the only formula that those two things can have is MgCl2, as you can see here. The reason for this is because anytime we are writing a formula, anytime we are forming a molecule from metals and nonmetals, the overall charge on the molecule has to be 0. It has to be neutrally charged. And so for things like magnesium and chlorine that only have one possible charge that they can have, there's only one way for those things to come together to give a net 0 charge. So our guiding principle through all of this that we're going to be doing here in this video is that the net charge on the molecule that we're making has to be 0. So when we take our positive charge and our negative charge and add them together, we have to get 0. It must be equal in terms of the overall magnitude of those two charges. To get those to balance out, if we have two things like magnesium and chlorine, for example, that don't have the same charge to start with, we're going to get those to balance with the subscripts, not the coefficients. Because remember, coefficients tell us, if we have 2 as a coefficient, that means we have 2 of everything in the whole molecule. And so that won't help us balance. The subscripts say we have 2 of just this one particular atom. So with magnesium and chlorine, again, as our example here, magnesium is going to have a charge of +2, and chlorine is going to have a charge of -1. Now, if you're thinking, where the heck did he get those from? They just kind of pulled that out of thin air. Remember, I don't remember how many videos ago it was. It might have been just recently. We talked about this. And I'm not entirely sure why that's so fuzzy. But we talked about how all of these elements want to have the same charge, or sorry, not the same charge. They want to have the same number of electrons as a noble gas. And so everything in this column is going to have one extra electron. It's going to have a charge of -1. Everything in this column is -2. Everything in this one is -3. Because, again, phosphorus, if it gains 3 electrons, will be the same as argon. We said this column was kind of the weird one. Sometimes it's +4, sometimes it's -4. For the most part, we're going to ignore this column. We might see it every once in a while, but the vast majority of what we're going to look at is either these 3 columns here or these 3 columns. And so over here, it's easier to lose electrons to become the same as a noble gas. So magnesium, for example, has 12 electrons, but if it loses 2 of those, it will have 10, just like neon. So then, sorry, I didn't realize all those markings were going to stick around on the screen here, but so magnesium is then +2 because it's lost 2 electrons. Chlorine is a halogen, and so it's going to gain 1 electron, so that you have +2, -1 for each of the chlorines, and so for those to balance out, you would need 2 chlorines. So you would have +2, and then 2 times -1 gives you a net 0 charge. And so that is going to be our our rules, essentially, our guiding principles for determining what the formula of an ionic compound is. The overall charge has to be 0, and we will use the periodic table to help us figure out what the charges on the individual atoms are. So we have a few examples here, but I'd like you to try and work out what the structures are, what the chemical formulas are for these on your own before I show you. So please pause the video for just a minute and work through and try to figure out what the formulas would be for each of these, which really, in a sense, what I'm saying is, what will the subscripts be here? Because we know that all of these are just going to be made up of these elements. Like, that can't change. We have to have the metal, which is the first one, and we have to have the nonmetal. We're not adding anything else in. We're not adding some other thing. We're not going to just throw hydrogen in randomly. It's just these two elements for each of the molecules. And so it's your task to figure out how many do I need of each of these to get the charge to balance. And one other thing really quickly before you give it a shot, we always want to find the smallest number that gives us an equal charge. So back here with this previous example, technically speaking, Mg2Cl4, that would also be balanced. But everything here is divisible by 2. It's not the smallest numbers we could use to get an equal charge. So that would be incorrect. We always want the smallest numbers possible. So all that being said, go ahead and figure out what the formulas would be for each of these. So pause the video now. All right, I hope you gave that a shot. First one here, sodium is +1, fluorine is -1, and so we actually don't need to do anything to this one. It is actually balanced the way I wrote it. You just need one of each to get a neutral molecule. Calcium and bromine. Calcium is +2. Bromine is a halogen. It's -1. So in this case, we do need 2 bromines. That will give us a neutral molecule. Calcium and sulfur. Again, calcium is still +2. It's in column 2, so it's +2. Sulfur is -2. So in this case, kind of similar to what we had just a second ago, we don't need any subscripts here because we have +2, -2. They already balance out. Strontium and phosphorus. The strontium is +2. It's in the same column as the calcium. Phosphorus is -3. So in this case, we're going to need 3 strontiums and 2 phosphorus. Phosphoruses, phosphori, whatever it is, whatever the proper plural is for phosphorus. And that is the smallest, those are the smallest numbers we can use to get a neutral molecule. Last one here, +2 and -3 again. And so once again, it's going to be 3 and 2. A good kind of shortcut for solving these, and which you might have noticed already, with these very simple ionic molecules, most of the time, to get the correct formula, what you can do is just take the charges on the 2 ions, swap them, and set them as the subscripts for the other ion. So if you notice here, the strontium had a charge of 2, phosphorus had a charge of 3, and the subscripts end up being flipped, essentially. So we had 3 here and 2 here. Same with the magnesium and nitrogen. And the same thing was true for calcium and bromine, And technically for sodium and fluorine as well, they were just both 1. So they both ended up with 1. That is almost always going to give you the correct numbers. The one exception to this would be if you had something like where one ion was +2 and the other one was actually, let's say one was +4 and the other one was -2. In that case, it wouldn't quite work out because you would have, let's just say for example, you had silicon, what would that be, silicon oxide. So silicon could be +4, oxygen could be -2. It wouldn't be correct to do this. It would still be neutral, so that is still correct. But again, kind of similar to what I mentioned just a minute ago, both of those are divisible by 2. So it's not the smallest numbers possible. It would be more correct to do SiO2. That would be the correct formula. So with the one exception of where you might have your numbers both divisible by some number, with that exception in mind, just swapping the numbers like that will almost always give you the correct answer. Alright, I think I won't go into nomenclature in this video. I think I'll save that for the next video just because I like to keep the nomenclature all together. So in the next video you'll get our introduction to nomenclature, which is just a fancy way of saying naming molecules. So I will talk to you in the next one.